multiplicity of at least 1. So then you try 2 again. Now you don't have to rewrite it. You just keep going in line there. All right, so you bring the 1 down, times 2, -1, -2, add them up. So it worked again. So we know the multiplicity is at least 2 this time. And then we try 2 yet again. And you just keep going here. You bring the 1 down, times 2. That's 1 times 2. And yet it works yet again. So you just keep trying it until it doesn't work. You could even try it a 4th time. It will not work this time, but you could keep trying it. Bring the 1 down. 1 times 2 is 2. So this is not 0. So we know that it does no longer work. Okay. Any questions on that?
No.
All right, so kind of as a little bit more though, this line right here, it becomes x plus 1 or 1x plus 1. Like every time you divide, it goes down by a power of, so this first one was x to the 4th per the original problem, x cubed, x squared, x. So you actually get that other root if you wanted. Does that make sense?
Yeah.
Because sometimes they want you to write it in factored form or give all the roots or something like that. Okay. On that page that I just grabbed this problem from, are there any other problems you want us to look at or need me to find one like this for you to work on or?
Those ones I think I've got that. So the multiplicity would be 3, right?
Yes. Sorry, I didn't even answer the question. Yes, the multiplicity is 3. And as a follow-up to that, does that mean it crosses or touches at that point? Cross or touch?
Um, touch.
So even touches, odd crosses. Does that make sense?
Yes.
Okay. All right. Any like it feels like we should go down and look at that bottom one, that f of x, x to the 5th, maybe.
Okay. Yeah.
What were the instructions for this one?
Um, this one says two distant zeros, and then um, x equals 3 and x equals 1.
What was the other one? I heard 3 and then
1.
okay. Huh. All right.
I can
So
send you. Do you want me to just send you the picture of the answer key thing?
yeah, if you want. What I was trying to decide is whether we should try these or not. And we probably should. Um, so let's just try them. What is that? Is that 169? I think it's 169. All right. So my guess is that these are going to work because of what you said.
It's 189.
Yeah,
Sorry.
it's really hard to tell. Yeah. Okay. So this is 54, 54 minus 108, minus 108, and then that becomes 81, 81, and 0. So you would normally try the number again and see if it worked. You basically try it until it doesn't work anymore. 11, 43, 43. So this is -50, 65, and you can see that this one does not work. All right, so we're done with one, but unfortunately you got to kind of go back to this line here. You go back to this line and you try 3. And I think this is going to work. So it does work. And so if it worked, like most things in life, you try it again. I'd like you to try 3 in here and tell me what this becomes, please.
You got um 3, -18, 27, and 0, and 1, -6, 9, and 0 on the bottom.
Okay, so it worked.
Yes.
Good. So 3 worked twice. Now this right here, what is this as a polynomial? Like, what does the 1 correspond to? X to what power at this point?
Squared.
Yeah, x squared minus 6x plus 9. So any power of 2, any quadratic like this, you're supposed to be able to solve. First you'd maybe try factoring, lots of other methods. I mean, you want to avoid using the quadratic formula. So what does this become? What does this factor into?
X -3, and
Okay.
then X +3.
So that the 3 and -3 do not multiply to positive 9. They have to multiply to positive 9, add to -6.
X -3.
Yeah.
Also,
Now, this suggests that we should have kept going with 3. But I would sort of argue that once you get it down to a quadratic, you ought to try something else. Is that okay?
yes.
All right. So this actually means that 3 works 4 times. Like if we go back to the original problem here, we know that it's 3 and 1. Um, we know that it's actually 3, 3, 3, 3, and then 1. So multiplicity of 4. Any questions on that?
No.
Okay. So now when I flip over the other page, we're going to, ooh, this is the more difficult stuff. So and you're going to get a problem like this on a test or quiz, where you have to write the polynomial. So this says, the instructions probably say to write the polynomial. There's a 0 at 5, and then at this 2 minus 3i. So what's really important is that someone tells you, or from class, that the roots come in what are called conjugate pairs, which means that it's also 2 plus 3i. These are both roots. 2 minus 3i and 2 plus 3i. Did you hear that in class? Do you remember that from class?
Yes, I do.
Okay. So the way you write it, and I think I saw this on the other page, you write x minus the root, x minus 5, x minus, now it's 2 minus 3i in parentheses, x minus 2 plus 3i in parentheses like that. Has to be in parentheses. Very, very important. All right, so now we're going to distribute that negative to both inside the parentheses, minus 2 plus 3i, x minus 2 minus 3i, and you do have to multiply this. Have you done that in class?
Um, kind of.
Okay, let's
Well,
go through at least one here. I'll have you do the other one. Uh, So it's like everything on the left multiplies everything on the right. So it's x times x is x squared. Then you have the x times the negative 2. That's minus 2x. Then x times the minus 3i becomes minus 3ix. And then you're done with the x, so you move to the minus 2. Minus 2 times x is minus 2x. I'm going to put that under the x's. Minus 2 times minus 2 is 4. Put that kind of off to the side here. 3i times minus 3i is minus 9i squared, like that. Is that okay?
Yes.
All right. Now we're going to take this 3i and multiply it by x. So that becomes 3xi, 3ix. The order doesn't matter. 3i times minus 2 is minus 6i. That's weird. Did I miss something? Sorry, I may have a mistake here. Um, so minus 2 times minus 2 is the 4. Minus 2 times minus 3i is plus 6i. Sorry, so I messed that one up. So now the last one, sorry about that, is 3i times x. That's 3ix. 3i times minus 2 is minus 6i. And then it's 3i times minus 3i is minus 9i squared. Is that okay?
Yes.
I know I fumbled that pretty badly, but that happens. So you just add vertically now. X squared minus 4x. The i's are all supposed to cancel. And that's why I was kind of stalling because I noticed that what I had originally wrote wasn't going to cancel and I was going to have some problems. All right, so then you get this plus 4. Now, what about this 9 minus 9i squared?
Um,
Do you remember what I squared is?
is it -1?
It is. So it's really minus 9 times negative 1, which is becomes plus 9. So x squared minus 4x plus 13. Is that okay?
Yes.
All right. So it feels like we did a lot of work, and we did, but there's more. You have to bring down that x minus 5, and now you have to multiply this out. Do you want to give that a try? There's no
Yes.
i's, so it's a little bit easier. I will do it as well in another window, and we can compare answers here.
Right now I have x cubed. Yeah, x cubed minus 4x squared plus 13x minus 5x squared minus 20x minus 65.
So it should be plus 20x. minus 5 times minus 4 is 20. Okay, so what does this add up to? Yeah, probably plus 65, not, sorry, not 65x.
So x cubed minus 9x squared plus 33x minus 65.
And you might think, I'm done. You're not. See how it's got this f of minus 7 equals 180?
Yes.
So there's really what's called an a out in front, or I guess we'll call this f of x. So it's an initial condition and it allows you to solve for the value of a. Now normally it's much easier than what's given there in your problem. Normally it's like f of 1 equals, 65 or something. Like it's not these awful numbers, but you do have to put in that -7 like that. And you're definitely allowed to use a calculator on this. Well, I would hope so. Okay, so that ends up being negative 1080. And so to solve for a now, you're going to divide both sides by that minus 1080. So a equals -1/10. And you might think, well, I must be done now, right? I must be done. It's turning into a horrible problem. Um, but some instructors want you to multiply this in to everything. And that's up to them. I don't get involved with all that. This last one does reduce, becomes 13/2. But I don't know how far you would be expected to go. Um, but this is kind of a monster problem for what you guys were doing. So the one to the right of it, I don't want us to do the whole thing. I don't think that's a great use of our time, but we can if you would like. But I would like to at least have you try this whole idea that, okay, I've got x minus a minus 2. That's one of the roots. X minus 3 minus 5i. X minus 3 plus 5i. So if you remember, those roots come in conjugate pairs like that. So what I want you to do, I think this would be a good thing here, is to have you try to multiply this out. Are you willing to give that a try?
Yes.
Okay. All right. So go ahead and work that out. I'm going to also do it on another screen here.
I got x squared minus 6x plus 9 plus 25.
That is correct. So it becomes x squared minus 6x plus 34 when you're all done. Really good. Any questions on that?
Mm,
Okay, so then from there and we don't have to do this, but we could. You would then multiply by x plus 2, and then you would have to find the initial condition. Do you want us to continue with this problem or move on to something else?
Move on, please.
Move on. Okay. You will get something like this on your test, so don't try to think, I hope I don't get this. That's the worst strategy. That's I want it. I know how to do it. I'm excited. Maybe. All right. You didn't say anything else over, did you?
No.
Okay. Looking at this graph touch. That's not right. Um, is this graph that's below those two problems here, is the equation below it related?
Um,
No, it can't be. It's gotta be the one on the right. Okay, yeah. Let me snip in what's on the right here, because and this will help to maybe close this out before we move on to rationals. Okay, what is the multiplicity of -1 based on the fact that it,
0.
so the multiplicity has to be, if it touches or crosses, it's at least 1. But if it touches, it's generally 2. So do you
Touches.
see, say it, go ahead. Is this function, or is this something totally different?
I think they go together, but it doesn't show on the paper.
3, okay. Because I'm looking here, um, like -1 should work, and it doesn't.
I think for the graph, we're supposed to find the decreasing or increasing.
Okay, that makes more sense. Um, okay. Do you want to do any more polynomial division or move on to other stuff like increasing, decreasing,
Um,
asymptotes, stuff like that, which is what's here.
Probably increasing and decreasing in asymptotes and stuff like that.
Okay, so a graph is increasing if it's going up and to the right. It's decreasing if it's going down and to the right. You always want to look at these things from left to right. Is that okay?
Yes.
All right. So now the first thing you do is you identify mins and maxes. So I'm going to put a red dot at the min or the max and a min. And then there's kind of one here. This is called something else, which won't make any sense until you take calculus if you ever do. Um, and the thing is that you only care about, and this is really hard for students, you only care about the x values. Okay, like you don't actually care about the you really don't care about the y's. And that may be hard to believe, but um, that is the case here. So in this first region where my cursor is it going up and to the right or down and to the right?
It's going down or up and to the right.
Up and to the right. Okay. So this graph is increasing from -infinity to -1. Now it's It's minus infinity, not because it's going down forever, it's because it's the x values. This goes to the left forever. Like anywhere over here, it's always coming up, right? Now, in this region right here, do you agree that it's also increasing, going up and to the right?
Yes.
Okay. We only care about the x values, 0.6 to 3. I don't care about the y value. Not important. Don't care. And then once you get past this point, do you agree that it is also increasing?
Yes.
It is. Okay. So that's from 3 to infinity. Your instructor may not care if you deal with the 3 this way, but it's actually neither increasing nor decreasing there at that point. It's just a little flat spot. So now decreasing, where is it going down into the right? Well, you can see is where my cursor is here. What is the x value, leftmost x value?
-1.
Yeah, from -1 to 0.6. All right, so let me grab some graphs here. See if we can do this. All right, so you may have to estimate these a little bit, but you only care about the x values. What are the x values at each of those places?
Um, -3. Is it -1?
-1's there, maybe -0.5, we'll say. Okay. So where is it increasing? Where is the graph going up and to the right?
Um, from -3 to 0.5. -0.5.
-0.5. Now where is it decreasing?
-0.5 to a negative infinity.
Okay, so the way you gave it to me there is there's actually two intervals. So let's what about this region over here? Like, isn't this decreasing?
Yes.
How far left does that go? Because you only care about the x values. How far left does the graph go?
Negative infinity.
Negative infinity to -3, it is decreasing. And then what about this next interval here?
And then is it -0.5?
To what? How far right does this graph go?
Infinity?
Yes. Okay. Questions on that?
No.
Okay. Let's try a much simpler graph, hopefully. Take a look at this and tell me where it's increasing, decreasing.
Then um increasing from 3 to infinity.
3 to infinity. Okay, agreed. And where's it decreasing?
Um infinity to 3.
Negative infinity to 3. Now, if you're wondering why it's negative infinity, it's because it goes to the left forever. It's the x values, not the y's. Is that okay?
Yes.
All right. Any questions on that?
No.
Okay, I think you've got that down. We can go back to your worksheet here. Um, Let me go back to this. Can you tell me what the instructions were? This is right below that graph that I had originally started that.
It says slant asymptote.
Oh, slant asymptote. Okay. So that's horrible. So you have to you have to do long division, polynomial long division. Let me not do that. X squared minus one outside the house, and then it's x cubed plus 0x squared plus 0x plus 1 inside the house. Do you remember this?
Yeah.
So this is really awful. I don't remember if we even did these, but maybe we did a few a week ago or more. Um, what do you figure out here? Like it's like you want to get rid of this x cubed. So I always look at it like, what do I multiply x squared by to to get x cubed
By an X.
by x? So that becomes x cubed minus 1x. And then very important that you change the signs. That way you're adding rather than subtracting. And it should always be the case that it cancels in the first position. So what's left over here? What when you add, what's the result?
0x squared plus x plus 1.
Yeah, so you don't need that. So you do at plus one. So the thing here is that you can't go any further because there's no way to get an x squared. I'm sorry, there's no way to get an x from the x squared. So you're kind of done. This right here is the answer. And that is your slant asymptote, y equals x. I know that's not a great explanation. This is not the best problem to start with for that. Um, it might have been better to do. These are all awful. It, was there one on the other side that was a slant asymptote?
It doesn't. None of them say slant asymptote other than that
Okay. Do you want us to do a better slant asymptote problem, or do you want this to be?
one. Yeah, we can do a better one.
Okay. Give me just a moment to look. Usually you start out with much better ones. I don't know. Okay. All right. So let's do. Oh, that one's not good. Okay. Let's try this one. All right. So the it's just like the previous problem. It would say, determine the slant asymptote. You put x plus 5 outside the house and x squared minus 6x plus 7 inside the house. So what I'd like you to do is figure out there's two things that you're trying to figure out. There's something that goes here and here, above the x and above the number. Could you attempt to work through that for me, please?
So do you start by putting x up top and then get 1x plus 7?
Yes, x there. So keep, go ahead and multiply that and then change the signs.
I get x plus 1 and then a remainder of 2.
So you said x plus 1?
I had x plus 1 on, or yeah, x plus
Okay.
1 on top and then a remainder.
So remember, you change the signs here. So it goes negative and negative. And when you add, you get negative 11x plus 7.
I see it. This is a remainder. I still have a remainder of 62.
Don't worry about the remainder. What's the number that goes here?
X minus 11.
You said, what, I'm sorry, one more time.
Minus 11.
Minus 11. There we go. That's good. So minus 11x minus 66. You change the sign. This is all you care about. This is the slant asymptote. So you actually don't care about that remainder, which may be a little bit uncomfortable or odd, but that is the case. Let's try another one here. Is that okay?
Okay. Yeah.
You're just dividing. You just got to be comfortable doing the division. It could be. Let's get one here. So x plus 3 outside the house, x squared minus 6x minus 1 inside the house.
Yeah, x minus 9 for that one.
So x, you said minus 9?
Yes.
X squared plus 3x, change the signs. Minus 9x, bring down the negative 1. Minus 9x minus 27. Very good. So that's your slant asymptote. There you go. That's perfect. Any questions on that?
No.
All right. So for the rest of this worksheet thing that you'd sent over here, like I see one that's maybe a quadratic type problem where they give you the vertex and a point. That would be kind of one for us to look at. What else stands out to you as maybe something to look at here in the next few minutes?
Can we do the vertex and the point one?
Yeah, so you have to remember that this is standard vertex form, x minus h squared plus k.
Is it x minus 6 squared plus 3?
So a x minus 6 squared plus 3. And then they're giving you an x and a y. So you're putting those in. 0 equals a, 3 minus 6 squared plus 3. Will you try solving that for a for us, please?
A equals -1/3.
Yeah, so it's minus 3 equals a times minus 3 squared, which is 9. So a equals minus 3 over 9, which is -1/3. And then you put that back in here. Well, it's the wrong spot. Back in here. So I'm going to scroll down here. So it's y equals -1/3 x minus 6 squared plus 3. I think we talked a little bit about expanded form. Do you remember how to expand this?
I do not remember.
So it's a foiling thing. You got to be able to foil
Oh,
this.
oh
So
yes, I did.
could you try doing that for us, please?
Yeah. Do you like distribute the 1/3 in or
Not yet.
whatever?
Not yet. Yeah. So it should get something like this. X squared minus 12x plus 36. And then you multiply in by the -1/3. So -1/3 x squared plus 4x minus 12 plus the 3. And then you can combine those. -1/3 x squared plus 4x minus 9. All right. We're going to stop there for today.